Hello and welcome to our presentation. Today we will discuss about applied maximum and minimum in calculus 1.
What is applied maximum and minimum? In Calculus 1, applied maximum and minimum problems refer to real-world applications where you use calculus to find the largest or smallest value of a function under certain conditions. These problems often involve optimization. For example, maximize the profit in a company or minimize the cost or find the least amount of material to make a particular object.
So here's the step to solve applied maximum and minimum problem. So the first one is to find the derivative, and then the next step is we let the derivative equal to 0 and find the value of the variable. And the third one is to do second derivative test. If the second derivative is more than 0, then it is a minimum value. If the second derivative is less than 0, then it is the maximum value.
The problem statement is the rectangular with a semicircular window of Farid's son house toy was broken. Farid plans to buy a new window glass. How much the area of the glass window that Farid need to order? It has a perimeter of 10 centimeter. So we can use applied maximum and minimum for this problem statement. The problem solution. First, we must express y in terms of x. So 10 equals to y plus x plus y for the perimeter of rectangular and plus pi r for the semicircular perimeter. R is equal to x over 2 because we use radius for x, not diameter. So the x must divide by 2. So we substitute r with the x over 2. So 10 equals to 2y plus x plus pi in bracket x over 2. So the pi will times with x over 2. So we got 10 equals 2y plus x plus pi x over 2. So we solve 20 equals to 4y plus 2x plus pi x. And we simplify to 4y equals to 20 minus 2x minus pi x because we want to express y in terms of x. So y must be single and the solution, the final answer will be y equals to 20 minus 2x minus pi x over 4. Next part is show that the area of the window is given by area equals to 40x minus 4x squared minus pi x squared over 8. So we write the equation area equals to x times y for the rectangular and plus half pi r square. We use half pi r square because semicircular. So the circle of area is pi r square. So semicircular, we use half pi r square. So next area equals to xy plus half pi x over 2 times 2. Like previous equation, we use x over 2 because we use half of the x to determine the radius of semicircular. So next area equals to xy plus pi over 2 or in bracket x power 2 over 4, and we solve area equals to xy plus pi x square over 8. We simplify it. So we substitute the value of y in the equation xy plus pi x square over 8. We get area equals to x in bracket 20 minus 2x minus pi x over 4 close bracket plus pi x square over 8, and we times the x with in bracket, and we get area equals to 20x minus 2x square minus pi x square per over 4 plus pi x square over 8, and we simplify it to area equals to 40x minus 4x square minus 2x square 2 pi x square plus pi x square over 8, and we simplify it to a equals to 40x minus 4x square minus pi x square over 8. So we prove that area is equal to 40x minus 4x square minus pi x square over 8. For the last part, we can determine the maximum area of the window. From the previous question, we get area equals to 40x minus 4x square minus pi x square over 8. So we differentiate that equation, we got 1 over 8 times 40 minus 8x minus 2 pi x. So the dA over dx must equal to 0. So we get 40 minus 8x minus 2 pi x equals to 0. So we bring 8x minus 2 pi x to the right. So we get 8x plus 2 pi x equals to 40. So we factorize 8x plus 2 pi x. We factorize that. So we get x times 8 plus 2 pi equals to 40. And we single that x. So we get x equals to 40 over 8 plus 2 pi. So we put that equation in the calculator, we can get x equals to 2.8 centimeter. So the question asks to determine the maximum area. So we use second derivative test to determine maximum or minimum value. So we differentiate the 1 over 8 40 minus 8x minus 2 pi x for the second time. So we get 1 over 8 times negative x minus 2 pi. So we get minus 1.7879. So we get the negative value, so we get maximum area. So we just substitute the equation from 40x minus 4x square minus pi x square over 8. We substitute x with 2.8, so we get 7 centimeter square.
So for our conclusion for this slide is applied maximum and minimum problems in calculus are very useful for solving many real life problems. These problems help us understand how to make the best use of resources, like maximizing productivity, reducing costs, or getting the best result while following certain rules. By using calculus, people and businesses can make better decisions, plan more effectively, and get better outcomes. Whether it's designing buildings, managing time, planning travel, or handling money, the ideas of applied maximum and minimum are important for being more efficient and reaching goals in daily life and work. So for our resources is from the Calculus 1 Revision book, page 49, diagram at example 11.